All right, let's get into it. Today we're going to crack open a tricky GCSE math question, but we're going to do it by going straight to the source, the official mark scheme. We'll see exactly what an examiner is looking for to give you those full marks.
So that's the big question, right? How do you take something that looks pretty complicated and just turn it into 4 easy marks? Well, let's break down a real exam problem and see exactly how it's done.
Okay, first things first, let's have a look at the actual problem we're dealing with today. And remember, this is from the non-calculator higher tier paper, so it's all about your own brain power here.
So here it is, question 17 from the November 2023 Pearson Edexcel paper. It's a 4-marker, and you can see it split neatly into 2 parts. Part 1 is all about factorizing an expression, and then part 2 asks us to solve an inequality using that.
Right, let's jump into part A. You need to factorize 6x squared minus 5x minus 4. This is one of those classic quadratics, where that number in front of the x squared isn't a simple 1, which can sometimes trip people up.
The method for this is actually pretty neat. First up, you take the first and last numbers, the 6 and the minus 4, and you multiply them. That gives us minus 24. Now for the puzzle part. We need to find 2 numbers that multiply to make that minus 24, but they also have to add up to the middle number, which is minus 5. And after a bit of trial and error, you get there. It's got to be minus 8 and plus 3.
So what do we do with these numbers? This is the clever bit. We use them to split that middle term, the minus 5x, into minus 8x plus 3x. Once you've done that, you can factorize the whole thing by grouping. You look at the first 2 terms, then the last 2, and boom, you see that common bracket, 3x minus 4, pop right out. That is the key to the whole thing.
And that little bit of algebraic magic brings us to our final factored expression for part A, 2x plus 1 multiplied by 3x minus 4. So that feels right, doesn't it? But the real question is that exactly what the mark scheme is looking for?
And yep, we checked the official mark scheme, and there it is. Our answer matches it perfectly. That's a solid 2 marks in the bag. Job done. Okay, let's move on to part B and see how it builds on what we just did. You know, these 2 parts are always connected for a reason.
Now look at the very first word of the question. It says hence. Anytime you see that word in an exam, it's basically a giant flashing neon sign from the examiner screaming, use your last answer. So we're not going back to the original expression. Nope. We're going to solve our factored version. It's the same problem, just way, way easier to work with now. So to solve any of these quadratic inequalities, the first thing we have to find are the critical values. And that's really just a fancy way of saying, where would this thing equal 0? Think of them as the key boundary points for our solution. And just like the mark scheme lays out, finding them is our next job. You just take each of those brackets, set them equal to 0, and solve for x. The first bracket gives us x equals minus 1/2, and the second one gives us x equals 4/3. Simple as that.
Okay, now we have to think about what the inequality actually means. Remember, this quadratic is a U-shaped curve. Since we want to know where it's less than 0, we're looking for the bit of the graph that dips below the x-axis. And that section is always going to be between the 2 points where it crosses the axis, which are our critical values. So our solution for x has to be somewhere between minus 1/2 and 4/3.
All right, so we've got the answer in our heads, but how do we actually write it down to get those final 2 marks? Let's check exactly what the mark scheme will accept.
And this is brilliant because it shows how flexible the mark scheme can be. It explicitly says you can write the answer as a single combined inequality or as 2 separate ones. Both are totally correct. They both get you full marks. The main thing you're showing is that x is trapped between those 2 values. It's bigger than minus 1/2 and smaller than 4/3.
So what's the big takeaway here? Well, it's that understanding the mark scheme isn't just about getting the right answer at the end. It's about showing your method, finding those key values, and presenting the solution exactly how an examiner wants to see it. Now that you've seen the whole process, which part of the mark scheme was most surprising to you?